Good evening everyone, good evening. I welcome you all again to JEE Enthuse. I hope all of you are doing great, having a good time. So people, you can first of all let me know in the chats if I'm perfectly audible and visible to everyone. Hello Dakshin, hello Aisha, hello Jyoti, hello Ishpreet, hello Sharik, hello Wajid, hi Georgina, hello Nandini, welcome back everyone. Welcome back people. Just give me some green signal from the chat so that I'll get to know first of all that I'm audible and visible to you guys properly. Yes? Let me know fast, my dear people. Let me know fast. Let me know fast. Let me know fast. Just give me a second, we'll be starting, yeah? Just give me a second. I'm doing great, Dakshin, how are you? I'm doing good, Arshad, how are you? Okay. Just a second, people. Let me fix the things. Yeah. Okay, so as you all must be knowing, tonight we are starting the sprint series, right, on this JEE Enthuse channel for the ones who are going to write the JEE in 2022, right? I hope you would have followed the Shreya sir's today's session, right? He also took the sprint session for the ones writing JEE in 2022, and now it's the time for chemistry, right? So, before starting the session, the ones who have just joined in, the ones who are new to the channel, let me quickly introduce myself. Well, people, my name is Wassim and I'm your chemistry master teacher writer on this JEE Enthuse channel, right? Well, the ones who have not liked the video yet, please do like the video, share the video with your friends, do subscribe to the channel, and do not forget to hit the bell icon so that you get the notification of every single session which we take live on this JEE Enthuse channel, right? So do like the video, share the video with your friends, and do subscribe to the channel as well, okay? So first of all, you guys can let me know in the chats if you all are super duper excited about the tonight's session. Let me know fast in the chats if you all are super duper excited about the sprint series, my dear people. Yes? Let me see the Josh of the session, then we'll be starting, yeah? Nandini says Josh is extremely high. That's wonderful. Yes, Aisha, we'll do that as well. No issues, we'll do that. Okay. So let's get going then. Let's get started with the first question, which is going to be on your screen in 3, 2, 1, and now. This is a very simple and basic question. Let's try to solve this. A very simple and basic. I'm starting exactly from the basics, right? Look at the question carefully, my dear people. The question says, chlorine has two isotopes which are Cl35 and Cl37. Average atomic mass of chlorine is 35.5 AMU. Find the percentage abundance of Cl37, right? Find the percentage abundance of Cl37. First of all, whenever you'll be having an element X which exists in the form of isotopes, let's assume this element has got isotopes, right, which have got same atomic number but different atomic masses. This is M1, this is M2, right? Let's assume this is the element which has got two different isotopes whose atomic number, which has got two isotopes with atomic number same but mass number different, M1 and M2, right? First of all, whenever you'll be having an element existing in the form of isotopes, at that time we calculate average atomic mass for this particular element, right? And in order to calculate average atomic mass for this particular element, what do you exactly need? You need the percentage abundances of these isotopes. And I'm assuming the percentage abundances of these isotopes is A and B respectively, right? Well, if you know the percentage abundance of these isotopes, you can simply use the formula to calculate average atomic mass for this element, which is simply going to be M1A plus M2B divided by A plus B. This is the general formula which you guys will be using in order to calculate the average atomic mass of an element which exists in the form of isotopes, right? As simple as that. Okay, and do remember the sum of percentage abundances of all the isotopes for a particular element, that's always 100. That's always 100. A plus B value will be always 100, right? Now I'm sure you guys can solve this question on your own now, right? It's given in the question that chlorine has got two different isotopes. One is Cl35, another one is Cl37, right? Well, the average atomic mass for chlorine is given to us as 35.5. What do I need to calculate? I need to calculate the percentage abundances of these two isotopes, right? Okay. Let's assume the percentage abundance of this Cl35 is X%. That means the percentage abundance of Cl37 is going to be 100 minus X, right? And percentage abundances we represent by A and B respectively, okay? So I'll be directly using the formula and get the value of A and B, right? MAB, what is going to be? It's going to be M1A plus M2B divided by A plus B. This value, as per question, is 35.5, right? This is basically the value of M1. This is basically the value of M2, right? So M1 value is given to me as 35. A value is X plus M2 value is 37. B value is 100 minus X divided by A plus B is 100. And this value in particular, it is equal to 35.5. Well, you got one equation which just contains one variable, that's X. When you solve this X, the value of X will come out to be 75%. If the value of X is coming out to be 75, that means the value of 100 minus X is going to be what? The value of 100 minus X is going to be 25%, right? So these are the percentage abundances of these isotopes which I was supposed to calculate, right? Is it clear to everyone? A very simple question. A very simple and basic question this was, based on the percentage abundances, right? So let's directly move on to one more question. See, this is one more basic question. I'm sure you guys can solve this again on your own, right? See, as per the question, calculate the following in 1.8 grams of glucose. So basically, I'm given with 1.8 grams of glucose. What do I need to calculate? I need to calculate total number of atoms, electrons, neutrons. All these things I'm supposed to calculate. How do we approach to this sort of a question? A very simpler one. Have a look. First of all, I will be calculating the number of moles of glucose. Number of moles of glucose is going to be equal to given mass of glucose divided by molar mass of glucose, which is 180 grams per mole, right? Yes, as simple as that. Right, people? Given mass of glucose, let's try to make it as 18 grams of glucose so that we can make calculation bit easy, right? Let's say in the question, it's given as 18 grams of glucose. Right? Let's assume it's mentioned in the question that we are given with 18 grams of glucose. So number of moles of glucose is going to be equal to mass of glucose divided by molar mass of glucose. The value comes out to be 0.1. The value comes out to be 0.1. So these many moles of glucose I have. Okay. So if I would want you guys to calculate the number of molecules of glucose, can you do that? Yes, it's simple. Number of molecules of glucose is going to be equal to number of moles of glucose multiplied by Avogadro's number. So these many molecules of glucose I'm having right now, right? Let's first of all calculate the total number of atoms present in 18 grams of glucose, right? Let's first of all calculate the total number of atoms. Have a look, guys. If you take one molecule of glucose, if you take one molecule of C6H12O6, right? How many total atoms are present in one molecule of glucose? It is 6 plus 12 plus 6. 6 plus 12 is 18. 18 plus 6 is 24. So there are basically 24 atoms present in one molecule of glucose, right? So can I say something like this? One molecule of glucose contains 24 atoms. And if one molecule of glucose contains 24 atoms, that means 0.1 Na molecules of glucose must contain 24 multiplied by 0.1 Na atoms. So these are the total atoms basically, which is coming out to be 2.4 Na. So these are basically the total number of atoms which are present in 18 grams of glucose. Isn't it simple? Right? Similarly, you need to calculate the number of electrons. See guys, how will I be calculating the number of electrons? Have a look. If you talk about glucose, right? C6H12O6, correct? If I ask you, what is the atomic number of carbon? You will say it is 6. If I ask you, what is the atomic number of hydrogen? It's 1. What is the atomic number of oxygen? It's 8, right? So these are basically the atomic numbers of these elements, carbon, hydrogen and oxygen respectively. Yeah. Now see guys, first of all, if the atomic number of carbon is 6, That means in one atom of carbon, there will be 6 electrons, right? In one atom of carbon, there will be 6 electrons. But do I have one atom of carbon or 6 atoms? I have 6 atoms, right? So 6 multiplied by 6. So basically, there are 36 electrons in 6 atoms of carbon. Similarly, atomic number of hydrogen is 1. That means in one atom of hydrogen, there is 1 electron. And similarly, there are 12 atoms of hydrogen. In one atom of oxygen, there are 8 electrons, but there are some 6 atoms of oxygen, right? So this value comes out to be 36, this value comes out to be 12, and this value comes out to be 48. Just calculate it, 6 to 8, 8, 8, 16, right? 3, 1, 4, 4, 1, 5, 5, 4, 9. So basically in one molecule of glucose, there are 96 electrons, right? In one molecule of glucose, there are 96 electrons. Can I say something like this? Can I say, in one molecule of glucose, we have got total 96 electrons, right? One molecule of glucose contains 96 electrons. If one molecule of glucose is containing 96 electrons, we can say 0.1 Na molecules of glucose will be containing 96 multiplied by 0.1 Na electrons. The value comes out to be 9.6 Na electrons. So these are basically the total number of electrons which are present in 18 grams of glucose, right? As simple as that. Similarly, in the similar way, you can calculate the total number of neutrons as well, and this is something which I'm giving you as the homework. In the similar way, the way I calculated the total number of electrons, in the similar way, you will be calculating the total number of neutrons and letting me know the answer of this question in the comment section afterwards, right? Okay. I'm directly moving on to one more question. This is one more question, guys. Let's try to solve this sort of a question as well, okay? The question says, at 27 degrees centigrade and 1 atm pressure, a given mixture of O2 and SO2 contains gases in 2:1 volume ratio. Calculate the number of moles present in 20 grams of mixture, right? See guys what the question says and what we are supposed to calculate. So basically, there is a container, and in this container, you have got O2 gas, and at the same time, you have got SO2 gas, right? Well, the temperature of this gaseous mixture is kept fixed, and the pressure of this gaseous mixture is again kept fixed, right? As per the equation, we have got a gaseous mixture containing oxygen and SO2, right? The pressure and temperature of this gaseous mixture, it's kept fixed, it's kept constant, correct? And at the same time, as per the equation, we are given with the total mass of the mixture as well, which is 20 grams. We are given with the total mass of the mixture as well, 20 grams. We are given with the volume ratio of these two gases as well, that is 2:1. This is the volume ratio of these gases which is given to me, right? Let me call this oxygen as gas 1, let me call this SO2 as gas 2. If I ask you, what is the molar mass of gas 1? What is the molar mass of oxygen? You should say 32 grams per mole. What is the molar mass of gas 2? What is the molar mass of SO2? It will be 64 grams per mole, right? The volume ratio of these two gases is given to us, right? Let me represent this with V1. Let me represent this with V2, correct? What am I supposed to calculate? I'm supposed to calculate the total moles present in 20 grams of mixture. I'm supposed to calculate total moles present in 20 grams of mixture. Isn't it going to be equal? Total moles present in the mixture is equal to mass of the mixture divided by molar mass of the mixture. But what do we call the molar mass of mixture as? We call it as the average molar mass. We call it as the average molar mass, okay? Is the mass of mixture given to me? Absolutely 20 grams. Now it is the time, first of all, to calculate average molar mass for this gaseous mixture, right? And there is one simple formula by means of which we can calculate average molar mass of the gaseous mixture, which is going to be equal to M1 multiplied by V1 plus M2 multiplied by V2 divided by V1 plus V2. M1 value, that is 32, V1 value, that is 2, plus M2 value, that is 64, V2 value, that is 1, divided by V1 plus V2 will come out to be 3. The value comes out to be 128 divided by 3. This is the average molar mass of the gaseous mixture. Now put this MAV value into this equation. It's going to come as 20 divided by 128 by 3. The value is going to be 60 divided by 128. So basically these are the total number of moles which are present in 20 grams of the mixture which we have taken in the container, right? Yes. Absolutely, NEET students can also watch it. Absolutely. People, is it clear to everyone? You got the concept behind this? Yeah? I was supposed to calculate the total moles present in 20 grams of the mixture, right? Which is equal to mass of the mixture divided by molar mass of the mixture. And molar mass of the mixture is something which I call as average molar mass, right? Yes? Gokul, it's a formula basically, bro. It's a formula. It's a formula to calculate MAV, to calculate average molar mass of the gaseous mixture. Do remember it from now onwards. Okay? Let's move on. Let's try to solve one more question. This is one more question, a very simple and basic question. Have a look. Calculate the volume of carbon dioxide and volume of oxygen consumed during the combustion of 128 grams of methane at STP, right? Again, a very simple question. Let's try to solve this, yeah? Let's try to solve this. Have a look. Have a look, guys. See, first of all, we are doing the combustion of methane, correct? We are making this methane to react with excess of oxygen. It is going to lead to the formation of carbon dioxide, and with this it's going to form water as well. This is the reaction which is going to happen when we do the combustion of any hydrocarbon, right? When we do the combustion of any hydrocarbon, this is the reaction which is going, these are basically the products of this reaction, okay? Now, calculate the volume of carbon dioxide liberated and the volume of oxygen consumed during the combustion of 128 grams of methane. So basically, as per the question, I'm doing the combustion of 128 grams of methane. I'm doing the combustion of 128 grams of methane, correct? So if I ask you, how many moles of methane do we have? It's going to be equal to given mass of methane, which is 128, divided by molar mass of methane, that is 16. The value will come out to be 8. So basically, we have got some 8 moles of methane. Basically, we are given with 8 moles of methane, correct? So when we are doing the combustion of 8 moles of methane, we need to calculate the volume of carbon dioxide which is getting liberated, and at the same time we need to calculate the volume of oxygen which is being consumed in the reaction, right? Now the point is, how do we do it? Have a look, guys. Have a look. First of all, let me try to balance this reaction. This reaction, let's try to balance. This should be 2 times, right? And this should be 2 times. Now it's a complete balanced chemical equation, right? Have a look. Stoichiometry coefficient right here is 1. Stoichiometry coefficient right here is 1. If I use the mole analysis, can I say 1 mole of methane liberates 1 mole of carbon dioxide? As simple as that. As per the stoichiometry of the reaction, I can say 1 mole of methane liberates 1 mole of carbon dioxide. If 1 mole of methane will be liberating 1 mole of carbon dioxide, can I say 8 moles of methane are going to liberate some 8 moles of carbon dioxide? As simple as that, right? So basically, I got the number of moles of carbon dioxide which are being liberated, right? Yes, I got the number of moles of carbon dioxide which are being liberated. That's equal to 8. But was I supposed to calculate moles of carbon dioxide liberated or volume of carbon dioxide liberated? I was supposed to calculate the volume of carbon dioxide liberated at STP, and I hope you remember how to convert moles into volume. I'm supposed to multiply moles with 22.4 liters, right? This value will come out to be how much? This value will come out to be 179.2, right? So these many liters of carbon dioxide are being liberated, right? These many liters of carbon dioxide are being liberated when we do the combustion of some 128 grams of methane, right? So one part of the equation is done. Yeah, let's move on and let's see the second part of the equation. As per the equation, we are supposed to see what is going to be the volume of oxygen which is consumed in the reaction. What is going to be the volume of oxygen which is consumed in the reaction? Now, how do I solve that part? See, guys, it's simple again. Can I say from the stoichiometry of the reaction, 1 mole of methane reacts with 2 moles of oxygen? Absolutely. Right? 1 mole of methane reacts with 2 moles of oxygen. If 1 mole of methane is reacting with 2 moles of oxygen, can I say 8 moles of methane will be reacting with 2 multiplied by 8, the value comes out to be 16 moles of oxygen, right? As simple as that. Right, people? So can I say these are the moles of oxygen which are being consumed in the reaction? These are the moles of oxygen which are being consumed in the reaction. But am I supposed to calculate moles of oxygen consumed or volume of oxygen consumed? I'm supposed to calculate volume of oxygen consumed in the reaction. And we know how to convert moles into volume. So I'll write volume of oxygen consumed will be equal to moles of oxygen consumed multiplied by 22.4 liters. This is basically the volume of oxygen which is being consumed as per the reaction, and that's something which I was supposed to calculate. Is that clear to everyone? You guys can let me know fast in the chats, yeah? You guys can let me fast in the chats if it's clear to everyone so that I can move on to the next one. All right, perfect. So let's try to move forward, and let's have a look on this question. The question was asked in your JEE 2021, right? The question was asked in your JEE Mains 2021. A very simple and basic question. Say, complete combustion of 3 grams of ethane gives A into 10 raised power 22 molecules of water. The value of A will be. So basically, as per this question, I'm doing the combustion of ethane, right? I'm making ethane to react with oxygen, and we know whenever you'll be having any combustion reaction, whenever we do the combustion of hydrocarbon, it always leads to the formation of carbon dioxide, and with this you'll be writing water as well. The first thing which I'll be doing in this case, I'll try to balance the reaction. Right? This should be 2 times, this should be 3 times, and when you try to balance the oxygen, it is supposed to be 2 plus 6 by 4. 4 2s are 8, 8 plus 6 is 14, 14 divided by 4. 14 divided by 4 means 7 by 2. Right? This is how we balance the reaction first of all. And let me show you exactly how do we balance these sort of reaction. Do remember from now onwards, whenever you'll be having a hydrocarbon in this way, CXHY, whenever you do its combustion, right, it's always going to lead to the formation of carbon dioxide and water. How do we balance this sort of a reaction? Understand. How many carbon atoms do we have right here? X. So I'll be keeping this X as the stoichiometric coefficient here. How many atoms of hydrogen do we have? Y. So I'll be keeping this Y by 2 as the stoichiometric coefficient over here. And what is going to be the stoichiometric coefficient of oxygen? Stoichiometric coefficient of oxygen, do remember, it's going to be X plus Y divided by 4. It's going to be X plus Y divided by 4. This is how we actually balance the combustion reaction of the general hydrocarbon, right? I'm sure you would have taken the note of it. Let's try to solve the equation now. What am I supposed to calculate? Complete combustion of 3 grams of ethane. So basically, I'm doing the combustion of 3 grams of ethane. So first of all, let me calculate the number of moles of ethane which we have. Isn't it going to be equal to given mass of ethane, which is 3 grams, divided by molar mass of ethane? This molar mass of ethane, 12, 12, 24, 24 plus 4 comes out to be 28, right? Yes? So basically, we have got some 3 divided by 28 moles of ethane with us, correct? As simple as that. Now have a look. If you talk about the stoichiometry of the reaction, over here the stoichiometric coefficient is 1. Right here the stoichiometric coefficient of the reaction is 3, correct? Yes? Now we will have a look. Can I say 1 mole of ethane gives 3 moles of water? As simple as that, right? Yes. 1 mole of ethane gives 3 moles of water. If 1 mole of ethane gives 3 moles of water, but do I have only 1 mole of ethane with me? No. I have got some 3 divided by 28 moles of ethane with me, right? So from 1 mole of ethane, just a second guys, it's not C2H4, right? It's C2H6. Sorry, my bad. It's C2H6. The molar mass of C2H6 is going to be 30, right? The value comes out to be 1 by 10. So basically I've got 1 by 10 moles of ethane. Correct? Now have a look. If 1 mole of ethane gives 3 moles of water, so I'll say 1 by 10 moles of ethane are going to provide 3 multiplied by 1 by 10 moles of water. Right? These are basically the number of moles of water which are being produced. Correct? But am I supposed to calculate the number of moles of water produced? Can number of molecules of water produced? I need to calculate the number of molecules of water produced, right? Yes? Correct? I need to calculate the number of molecules of water produced. So I'll say number of molecules of water produced is going to be equal to number of moles of water, 3 divided by 10, multiplied by Avogadro's number, right? 6.022 into 10 raised power 23. Correct? As simple as that. So this value, so these are basically the number of molecules of water which I was supposed to calculate, right? These are the number of water molecules which I was supposed to calculate, which is coming out to be 3 multiplied by 6.022 into 10 raised power 22. Correct? So this was basically 0.3. I converted it into as 3 into 6.022 into 10 raised power 22, right? Now compare this term with this term. You can clearly say your A value right here is equal to 3, and that's something which I was supposed to calculate. So A value is coming out to be 3, right? Yes? Right, people? A value is coming out to be 3. Is that? Is that? Or wait, number of molecules is 0.3 multiplied by 6.022 into 10 raised power 23. Okay, there was no 6.022 into 10 raised power 23 over here. So what you'll be simply doing, you'll be just multiplying these two things. The final value is going to be 18.069 into 10 raised power 22, right? So this value, A value, you are going to get as 18, not as 3, okay? I thought over here it's given as A into 6.022 into 10 raised power 22. I hope you got it. Yeah? Yes? Yes, Muzammil, exactly. Okay, let's move on to one more question. This is one more question on the screen. Let's try to solve this sort of a question as well, okay? Have a look, people. Calculate the mass of H2SO4 which contains 0.25 moles of oxygen atoms. How do we solve this sort of equation? Right? Understand. First of all, if I take 1 mole of H2SO4, if I take 1 mole of H2SO4, can I say 1 mole of H2SO4 contains 4 moles of oxygen atoms? I can say that. Right? Yes? Yes, Muzammil, I teach at NEET Elite at the same time. Right, right. 1 mole of H2SO4 contains 4 moles of oxygen atoms, correct? If I just reverse the statement, can I say 4 moles of oxygen atoms, 4 moles of oxygen atoms are present in 4 moles of oxygen atoms are present in 1 mole of H2SO4, right? I can say something like this. Correct? Yes? 4 moles of oxygen atoms are present in 1 mole of H2SO4. So can I say 1 mole of oxygen atoms must be present in 1 divided by 4 moles of H2SO4, right? Can I say 0.25 moles of oxygen atoms must be present in 1 by 4 multiplied by 0.25 moles of H2SO4, right? Yes? Now we will have a look. What is this term over here? What is this term over here? These are basically the moles of H2SO4 which actually contains 0.25 moles of oxygen atoms, right? These are basically the moles of H2SO4 which contains 0.25 moles of oxygen atoms. But do I need to calculate the moles of H2SO4? No way. I'm supposed to calculate the mass of H2SO4, right? Yes, I need to calculate the mass of H2SO4 which contains 0.25 moles of oxygen atoms. So in order to calculate the mass of H2SO4, what am I supposed to calculate? I'm supposed to multiply the moles of H2SO4, which is 1 by 4 multiplied by 0.25, with the molar mass of H2SO4, that's 98. Now it's going to be your turn to solve this part and get the mass of H2SO4 in grams, right? So people are saying the value comes out to be 6.125, all right? So people are saying the value is coming out to be 6.125 grams. What it means exactly? It means 6.125 grams of H2SO4 will be exactly containing 0.25 moles of oxygen atoms, right? Yes? As simple as that. Correct? Now, if you look at the second part of the equation, look at the second part of the equation. See guys, how do we solve the second part of the equation? Understand properly, okay? Understand properly. Understand properly. So, in order to solve the second part of the equation, can I say 1 mole of H2SO4 contains 2 moles of oxygen molecules? Can I say something like this, right? Few minutes back I told you 1 mole of H2SO4 contains 4 moles of oxygen atoms. But in this particular case, I'm telling you, 1 mole of H2SO4 contains 2 moles of oxygen molecules, not the atoms, right? Not the atoms. Perfect. Now have a look. If I just reverse the statement again, can I say 2 moles of oxygen molecules, right? 2 moles of oxygen molecules are present in 1 mole of H2SO4, right? Yes, as simple as that. So can I say 1 mole of oxygen molecules will be present in 1/2 moles of H2SO4, right? 1 mole of oxygen molecules will be present in 1/2 moles of H2SO4. So can I say 0.25 moles of oxygen molecules will be present in 1/2 multiplied by 0.25. Instead of 0.25, you can write 1/4 moles of H2SO4. So this value is coming out to be 1/8. So what is this 1/8 basically? These are actually the moles of H2SO4 which contains 0.25 moles of oxygen molecules, correct? But am I supposed to calculate moles of H2SO4? No way. I'm supposed to calculate the mass of H2SO4. So what is the thing which I'll be doing the next? I'll be multiplying these moles of H2SO4 with its molar mass, right? And the molar mass of H2SO4, you guys know, that's 98. So 1/8 multiplied by 98, the value comes out to be 12.25, right? So I'll say the mass of H2SO4, which contains exactly 0.25 moles of oxygen molecules, it's going to be moles of H2SO4 multiplied with its molar mass, the value comes out to be 12.25, right? So these many grams of H2SO4 will be containing exactly 0.25 moles of oxygen atoms. I'm sure this is clear to everyone, right? Yes? You guys can let me know in the chats if you want me to move on to the next one. Perfect. Okay, so let's move on to one more question then. This is one more simple question, right? Let's see exactly how this sort of a question is to be solved. Well, whatever questions we solved till now, we solved the questions on the basis of mole-mole analysis, right? Now let's try to solve certain questions by mass-mass analysis as well, okay? Till now, whatever questions I've shown you, all the questions we have done by means of mole-mole analysis. Now the coming questions, let's try to solve them by mass-mass analysis, right? Yes, Arshad, tomorrow states of matter lecture will be there, right? The thumbnail is already updated on NEET Lead channel. You can check it out. Okay, look at the question carefully. The reaction that's given to me, that's 4 times HCl plus MnO2. It gives MnCl2 plus 2 times water plus Cl2. This is the reaction that's given to me, right? Now have a look. How much HCl is needed? How much HCl is needed for complete reaction with 69.6 grams of MnO2, right? Yes? Right, people? How much HCl in grams is needed to react with 69.6 grams of MnO2? That's something I'm supposed to calculate, okay? Let's see exactly how to solve this sort of equation. Understand? So if I ask you first of all, what is the molar mass of HCl? You will say molar mass of HCl is 36.5 grams. What does that mean? That means mass of 1 mole of HCl is 36.5 grams, right? Yes, mass of 1 mole of HCl is 36.5 grams. But do I have 1 mole of HCl? 4 moles of HCl. I've got 4 moles of HCl. So what is going to be the mass of 4 moles of HCl? These many grams, right? What about the molar mass of MnO2? It's mentioned in the question that it's 87 grams. So 87 grams, this is the molar mass of MnO2, or you can say this 87 grams, this is the mass of 1 mole of MnO2, correct? Right? Now people understand. Can I say something like this? Can I say as per the stoichiometry of the reaction, 87 grams of MnO2, can I say 87 grams of MnO2 as per the stoichiometry reacts with 4 multiplied by 36.5 grams of HCl. I can say something like this, right? I can say something like this, correct? Simple. 87 grams of MnO2 reacts with these many grams of HCl. So 1 gram of MnO2, it reacts with 4 multiplied by 36.5 divided by 87 grams of HCl, right? So you got to know exactly 1 gram of MnO2 reacts with these many grams of HCl. But do I have 1 gram of MnO2 with me? No. I've got some 69.6 grams of MnO2. So can I say 69.6 grams of MnO2 reacts with 4 multiplied by 36.5 divided by 87 multiplied by 69.6 grams of HCl. Now it's going to be your turn to solve this part, right? Solve this part. And this is basically going to be the mass of HCl. This is going to be the amount of HCl. This is going to be the mass of HCl, which exactly reacts with 69.6 grams of MnO2. And that's something I was supposed to calculate, right? You guys can let me know in the chat if it's clear to every single guy. Yeah? Right? Let me know fast, people, if it is clear to everyone, so that I'll move on to the next question. Yes, I'm from a cold area. That's called as Kashmir. Perfect. Okay, so let's move on then to one more question. Okay. All right, this is one more type of question. Let's try to understand and let's try to solve these sort of questions as well. Okay. See guys, look at the question carefully. And this question was once asked in your JEE Mains like long back. Yeah, when it used to be IIEEE examination. Have a look. A gaseous mixture of propane and butane. So basically, as per the question, I'm given with a mixture. I'm given with a gaseous mixture which contains propane C3H8 and at the same time it contains butane C4H10. So this is the gaseous mixture which I have as per the question. Right? This is the gaseous mixture which I have as per the question. And what is the volume of this complete gaseous mixture? The volume of this complete gaseous mixture is 3 liters. 3 liters is the volume of the gaseous mixture. Now what we are doing exactly? We are doing the combustion of this gaseous mixture, right? We are doing the combustion of this gaseous mixture. We are making this gaseous mixture to react with oxygen, correct? Right? We are making this gaseous mixture to react with what? To react with oxygen, correct? And when this gaseous mixture undergoes combustion, as per the question, 10 liters of carbon dioxide is being liberated. Volume of carbon dioxide which gets liberated after the combustion of 3 liters of this mixture, it is given to me as 10 liters, right? This is the volume of carbon dioxide. This is the volume of carbon dioxide which gets liberated after the combustion of these 3 liters of the mixture. What do I need to calculate? I need to calculate exactly the volume of propane and butane in the mixture, correct? See guys, how do we solve this sort of equation? First of all, when O2 will be introduced in this container, can I say some part of O2 will be reacting with propane and some part of O2 will be reacting with butane? Absolutely. Yes. Right? So there will be 2 reactions basically. I'll say some part of oxygen is going to react with propane and it will lead to the formation of carbon dioxide and water, and the remaining part of oxygen is going to react with butane, right? The remaining part of oxygen is going to react with butane and it will lead to the formation of carbon dioxide and water again, right? Yes? Number of elements, 118. There are 118 elements in the periodic table, right? That's what you're asking? Okay, see. So first of all, let's try to balance both the reactions. This is 3 over here, so this must be 3. This is 8, so this must be 4. This will be 5 times. This reaction is balanced, right? This reaction is balanced, okay? Now similarly, this is 4, so this will be 4. This is 10, so this should be 5. This will be x plus y by 4. So 4 plus 10 by 4. 4 plus 10 by 4. This is going to be 2, 5. 2, 2. 4 2s are 8. 8 plus 5, 13. So it's going to be 13 divided by 2 times, right? Okay. Few minutes back only I told you how do we balance the combustion reactions, okay? Now understand. The total volume of the gaseous mixture is 3 liters. Let's assume out of these 3 liters of gaseous mixture, we have got some x liters of propane. So the remaining is going to be 3 minus x liters of butane. This is the remaining volume of what? Butane in the container. This is the volume of propane in the container. This is the volume of butane in the container. Now understand. The stoichiometric coefficient right here is 1. The stoichiometric coefficient right here is 3. Can I say 1 liter, as per the stoichiometry of the reaction, 1 liter of propane produces some 3 liters of carbon dioxide? Absolutely. As per the stoichiometry, right? As per the stoichiometry. Yes. Right? 1 liter of propane liberates 3 liters of carbon dioxide. If 1 liter of propane liberates 3 liters of carbon dioxide, can I say X liters of propane are going to liberate 3x liters of carbon dioxide. So basically, this is the volume of carbon dioxide which gets liberated from reaction number 1, right? Similarly, there will be some volume of carbon dioxide which will be getting liberated from reaction number 2 as well. Yeah. Now see, the stoichiometric coefficient right here is 1, the stoichiometric coefficient right here is 4. Can I say 1 liter of butane produces some 4 liters of carbon dioxide? If 1 liter of butane produces some 4 liters of carbon dioxide, so can I say 3 minus x liters of butane, 3 minus x liters of butane are going to produce 4 multiplied by 3 minus x liters of carbon dioxide, right? So this is the volume of carbon dioxide which is being liberated from reaction number 2, right? What is the total volume of carbon dioxide which is getting liberated? That's 10 liters, right? So this 10 liters, out of this 10 liters of carbon dioxide, there will be some liters of carbon dioxide getting liberated from reaction number 1, and there will be some liters of carbon dioxide getting liberated from reaction number 2. What is the concept which I'll be using? The concept will be number of moles of carbon dioxide which get liberated by reaction number 1 plus number of moles of carbon dioxide which get liberated from reaction number 2 should be equal to the total volume of carbon dioxide liberated, right? Yes. So volume of carbon dioxide liberated from reaction number 1, that's 3x, plus volume of carbon dioxide liberated from reaction number 2, that's 4 multiplied by 3 minus x is equal total volume of carbon dioxide liberated, that's 10, right? So the value will be 3x plus 12 minus 4x is equal to 10. From this calculation, you will be getting the value of x as 2 liters, right? What was x? X was basically the volume of propane in the mixture. So it's going to be 3 minus x, that means 3 minus 2. The value comes out to be 1. So volume of butane in the mixture is going to be 1 liter. That's something which I was supposed to calculate, right? Yes. So volume of propane in the mixture is going to be 2 liters. And volume of butane in the mixture is simply going to be 1 liter. That's something I was supposed to calculate. You guys can let me know in the chats if it is clear to every single guy so that I can move on directly to one more question. Yeah? That's great, Vani Ayan. That's great. I'll see you tomorrow in the class itself. Yeah. No, Abhijit, this session is not going to be too long. No. We'll end this session on time. Yeah? Yes. Okay. Let's try to move on to the next one. This is one more type of question based on, again, the mixture analysis only. One more type of question. Rajan, you can do one thing. Nambi Rajan, you can just drag the video a little back. It'll be automatically a replay for you, okay? Right? That's the benefit of the live session, correct? You can just drag the video back. It'll be a replay for you. You can check it out. Okay. Let's try to solve this question as well. This is a bit lengthy, but it's simple at the same time, okay? Say, as per this question, we are given with a mixture which contains 1 gram of an alloy, right? We have gotten 1 gram of an alloy containing magnesium and aluminium. So basically in the container, we have got magnesium and aluminium. And actually, we have got 1 gram of this mixture. So the mass of this complete mixture is 1 gram, right? So first of all, I'll be assuming out of 1 gram, let's assume there are some x grams of magnesium in the container. So aluminium is going to be 1 minus x grams, right? This is the mass of magnesium in the mixture. This is the mass of aluminium in the mixture. If I divide this term by the molar mass of magnesium, can I say this is now becoming the number of moles of magnesium in the container? And similarly, 1 minus x divided by 27, which is the molar mass of aluminium, can I say this is now becoming the number of moles of aluminium in the container, right? Yes. These are the moles of magnesium in the mixture. These are the moles of aluminium in the mixture. That's something which I did first, right? Now understand. Now, what am I doing? Inside this container, I'm putting HCl. Right? When I introduce HCl into this container, what is happening? As per the equation, 1.12 liters of H2 is being liberated. When I introduce HCl into this container, as per the equation, volume of H2 which gets liberated is equal to 1.12 liters. So basically, these many liters of H2 are being liberated when HCl is introduced in this container, right? Yes? Right? So basically, we have got magnesium and aluminium, right? This is not some aluminum. What are you saying? Okay, this is magnesium and aluminium, correct? I'm introducing HCl into this container, and as per the question, what's happening? 1.12 liters of hydrogen gas is being liberated, right? So if I ask you first of all, how many moles of H2 gas are actually being liberated at STP? Right? I'm asking you, how many moles of H2 gas are being liberated at STP in total? Yeah? Say guys. Total moles of H2 gas which are being liberated as per the question, it's going to be equal to given volume of H2 gas divided by 22.4 liters. So these are basically the total moles of H2 gas which are being liberated as per the question, correct? Now understand. When I put HCl into this container, can I say some part of HCl will be reacting with magnesium and some part of HCl will be reacting with aluminium, right? Yes. So what is going to happen? When magnesium will react with HCl, what is going to happen? The reaction will take place and you will get MgCl2, and with this MgCl2, H2 gas will be getting liberated at the same time, right? Similarly, aluminium is going to react with some part of HCl as well, and it's going to lead to the formation of AlCl3, and with this H2 gas gets liberated at the same time, right? So basically, these were the total moles of H2 gas being liberated, right? So can I say, out of these total moles of H2 gas which are getting liberated, few moles of H2 gas will be liberating from this reaction and few moles of H2 gas will be liberating from this reaction. Yes? What is the concept which I'll be using? I'll say number of moles of H2 gas which get liberated from reaction number 1 plus number of moles of H2 gas which gets liberated from reaction number 2 should be equal to the total moles of H2 liberated, right? Yes? Now how do I approach this sort of equation? Understand. Let's try to balance the reactions first. This should be 2 times. This should be 3 times, this should be 3 by 2 times. The reaction is balanced, right? Or both the reactions are balanced. Now understand. The stoichiometric coefficient right here is 1. The stoichiometric coefficient right here is 1. Can I say 1 mole of magnesium produces 1 mole of H2 gas? Absolutely. 1 mole of magnesium produces 1 mole of H2 gas. But do I have only 1 mole of magnesium with me in the container? No. I have got some X by 24 moles of magnesium with me, right? So if 1 mole of magnesium produces 1 mole of hydrogen, so I can say X divided by 24 moles of magnesium are going to produce X divided by 24 moles of hydrogen. So basically, what did I get? I got the moles of hydrogen which are being produced from reaction number 1. Similarly, there will be some moles of hydrogen which will be getting produced from reaction number 2. And how do we check that? The stoichiometric coefficient right now is 1. The stoichiometric coefficient right here is 3 by 2. Can I say 1 mole of aluminium produces 3 by 2 moles of hydrogen? Absolutely. Right? 1 mole of aluminium produces 3 by 2 moles of hydrogen. If 1 mole of aluminium produces 3 by 2 moles of hydrogen, can I say 1 minus X by 27 moles? 1 minus X divided by 27 moles of aluminium will be producing 3 by 2 multiplied by 1 minus X divided by 27 moles of hydrogen, right? What is this term? These are the moles of hydrogen which are being liberated from reaction number 2, right? Yes? Right, people? These are the total moles of hydrogen which are being liberated. And these total moles of hydrogen are being liberated from reaction number 1 as well as reaction number 2. I can say some of the moles of hydrogen are being liberated from reaction number 1, some of the moles of hydrogen are being liberated from reaction number 2. So the concept which I'll be using, that is going to be the number of moles of hydrogen which are being liberated from reaction number 1 plus number of moles of hydrogen which are being liberated from reaction number 2 should be equal to the total moles of hydrogen liberated, right? Yes? So I'll just make an equation. The moles of hydrogen which are being liberated from reaction number 1 plus moles of hydrogen which are being liberated from reaction number 2, which is 3 by 2 times 1 minus X divided by 27 should be equal to total moles of hydrogen which are being liberated, right? Okay, so I got one equation which just contains one variable. And what is the variable? Variable is X. So by solving this equation, you can get the value of X. And what was X basically? X was the mass of magnesium in the container. And if you get the value of X, you can calculate 1 minus X as well, right? You can calculate 1 minus X as well. Okay, that's something which is going to be the mass of aluminum in the mixture, right? And those were the things which I was supposed to calculate, right? Yes? Is that clear to you? Is it clear to everyone, right? Let me know fast. Let me know fast. If it is clear to everyone. Okay. Perfect, guys. So let's move on then to one more question. I have no idea like how many more questions are there. Okay. There is one more question. The question is simple. Calculate the mass of P4O10, right? Calculate the mass of P4O10 obtained when 1.24 grams of P4 reacts with 1.92 grams of oxygen. So as per the question, first of all, P4 is reacting with oxygen and it leads to the formation of P4O10, right? I'll first of all balance the reaction. This should be 5 times. So as per the question, first of all, what is the mass of P4 that's given to me? 1.24, right? Let's calculate the number of moles of P4 first of all, which are given to me. It's going to be given mass of P4 divided by molar mass of P4, which is 124. The value is going to be 0.01, right? Yes, these many moles of P4 are given to me initially, correct? Similarly, let's calculate the number of moles of oxygen which are given to me. It will be equal to given mass of O2 divided by molar mass of O2. Can you let me know what is this value coming out to me? Fast. Can you let me know what is this value coming out to me? I'm waiting for your answers. Let me know fast. Just do it, let me know. 1.92 divided by 32. It's going to be 0.6, right? Yeah? Is it going to be 0.6? Correct? 0.6 or 0.06? It's going to be 0.06, right? Okay. So first of all, as per the question at time t is equal to 0, initially, I'm given with 0.01 moles of P4 and at the same time, I'm given with 0.06 moles of O2. So initially at time t is equal to 0, how many moles of P4 would have got formed? 0, right? Remember, whenever you'll be having a reaction in which the amounts of all the reactants will be given, at that point of time, you'll be always using the concept of limiting reagent. And how do we use the concept of limiting reagent? What you simply are going to do, you'll be first of all balancing the reaction, and I've already balanced the reaction. Now you are going to identify which one among the two is going to be the limiting reagent, right? You're going to identify which one among the two reactants is going to be the limiting reagent. Now the point is, how do we identify which one is the limiting reagent? Understand. Just divide the given moles of reactants by their respective stoichiometry coefficients, right? By their respective stoichiometry coefficients. Which value will come out to be less? This value will be 0.01. This value will be 0.012. Which value is lesser? This value is lesser, right? So the one which has the lesser value, that is going to be your limiting reagent. So P4, you got to know exactly that's your limiting reagent. And if P4 is the limiting reagent, it would have got completely consumed in the reaction, right? And you guys must be knowing, entire product is decided by the limiting reagent, right? Entire product is decided by the limiting reagent. Now, limiting reagent is going to decide the amount of product which is going to get formed. Yeah? Have a look. Stoichiometric coefficient right here is 1. Stoichiometric coefficient right here is 1. Can I say 1 mole produces 1 mole? 1 mole produces 1 mole. So 0.01 moles are going to produce 0.01 moles, correct? So basically, I got the number of moles of P4O10 which are getting formed at the end of the reaction. It is 0.01, correct? But was I supposed to calculate the number of moles of P4O10? Calculate, right? I was not supposed to calculate the number of moles of P4O10. I was supposed to calculate the mass of P4O10. So I'll be converting these moles of P4O10 into mass of P4O10. It's going to be equal to given mass of P4O10 multiplied by molar mass of P4O10. And what is the molar mass of P4O10? That's something which you'll be calculating, right? What is the molar mass of P4O10? Let's check it out. P4O10. Phosphorus is 31, right? There are 4 phosphorus atoms, 4, 1, 4. So it's 124, right? And there are 10 oxygen atoms. So 124. One oxygen atom will have the molar mass of 16. So 10 oxygen atoms will be having the molar mass of 160, right? So this is 4, 6 to 8, right? 284, correct? 284 is the molar mass of P4O10. So I'll be multiplying it with 284 grams, right? So this is basically going to be what? 2.84 grams, correct? So 2.84 grams of P4O10 will be formed at the end of the reaction, right? That's something which I was supposed to calculate. I'm sure it's clear to everyone, yeah? Right, people? Is it clear? Should I be moving on to one more? Should I be moving on to one more? Right? Yeah? Okay. Well, this is one more question which is based on the limiting region concept only. So let's try to solve this one as well. Let's try to solve this one as well. Okay? Well, I'm given with the reaction which is already given to me in the balanced form. It is 6 times LiH plus 8 times BF3. Again, a very simple and basic equation. It gives 6 times LiBF4, and at the same time, it's producing B2H6 as well. Okay? Now, at time t is equal to 0 initially, at time t is equal to 0, I've got some 2 moles of LiH. I've got some 2 moles of BF3 at the same time. This is going to be 0, this is going to be 0, right? Yes? Simple? Okay? See people, it's very simple. I'm given the reaction, and initially, I'm starting with 2 moles of each of the reactants, right? As I told you a few minutes back. Whenever you will be given with the amounts of all the reactants, at that point of time, you'll be using the concepts of limiting reagent, right? So, over here, the first step in order to use the limiting reagent is to balance the reaction, correct? And the reaction is given in the balanced form itself, yeah? Now, it's time to identify the limiting reagent. And how do we identify the limiting reagent? That's something which every one of you would be knowing. You're supposed to divide the given moles of reactants by their respective stoichiometric coefficients. Stoichiometric coefficient over here was 6, stoichiometric coefficient over here was 8, 2 by 6 or 2 by 8, which value is lesser? 2 by 8, this value is lesser. And the one which gets the lesser value, that's always going to be the limiting reagent. So I got to know BF3 is the limiting reagent, yeah? So people, if BF3 is a limiting reagent, can I say entire BF3 would have got consumed? So after some point of time, there will be some 0 moles of BF3 left in the container, right? And entire product is governed, it's decided by it's decided by the limiting reagent, right? Yes. Now, how do I get to know exactly the moles of B2H6 which are getting formed? Simple. Use the stoichiometry. 8 moles of BF3 produces 1 mole of B2H6. So 8 moles of BF3 produces 1 mole of B2H6. So 1 mole of BF3 will be producing 1 by 8 moles of B2H6. So 2 moles of BF3 will be producing 1 by 8 multiplied by 2. The value is going to be 1 by 4, right? 0.25. So at the end of the reaction, you will find some 0.25 moles of B2H6 that would have got formed right at the end. Yeah? So these many moles of B2H6 would have got formed at the end of the reaction, right? Yes? Right? Perfect. Right, people? Let me know fast in the chats if it is clear. Okay. All right, this is one more question. Let's try to solve this one as well. Yeah? See. We are given with a compound, and the compound is M dot X times water. This compound contains some 40% of water by mass. It contains 40% of water by mass. Well, the molar mass of M is given to me as 189. Find value of X, right? There is one simple formula which every one of you would be knowing. If I say percentage of water in this compound, it's going to be equal to mass of water in this compound divided by molar mass of the compound multiplied by 100. This is the simplest formula which I'll be using in order to calculate the percentage of water in this compound, right? Well, the percentage of water in the compound is given to me as 40, correct? Is equal mass of water, right? First of all, in 1 mole of the compound, how many moles of water do I have? In 1 mole of the compound, I have got some X moles of water, right? What is the mass of 1 mole of water? It's 18 grams. So what is going to be the mass of x moles of water? It's going to be 18x grams, right? Divided by molar mass of compound. Molar mass of compound is going to be molar mass of this element plus molar mass of x moles of water, right? So it's going to be molar mass of this metal M is going to be 189 plus it's going to be 18x, right? Multiplied by 100. So you got one equation which just contains one variable, that's x, right? Well, you can solve x from here, okay? And that's something which I was supposed to calculate, I believe, right? Find the value of x, correct? You got one equation which contains one variable, and finally, you'll be getting the value of x approximately equal to 7, right? Yes? Is it clear to everyone? Yeah? Perfect. This is one question which I'm giving you as the homework. Do let me know the answer of this question in the comment section afterwards, right? So people, with this, I'm going to end the session, right? I'm not done with all the questions of mole concept, right? The sprint of mole concept is not done yet. There will be one more session for this mole concept, right? In which I'll be doing the rest of the things which are there in the mole concept, okay? This was the lecture number 1, and in lecture number 2, we'll be completing this mole concept of the sprint series, right? Okay, I'm sure every single thing would be clear. Yeah? Right? Yes, Shashant, I come live on this channel every day at 10:30. Okay? So please have a look on the thumbnail. You'll get to know in the community post when I'll be taking the lecture number 2 for this mole concept sprint. Okay? That involves percentage yield, percentage purity, then the concentration terms and the empirical molecular formula. So the next session of mole concept in the sprint, okay, these are the topics from which the questions I'll be coming up with. One is going to be percentage yield, second percentage purity, then there will be the empirical molecular formula, and at the same time the concentration terms are as well. Okay, perfect. Well, before ending the session, let me just quickly tell you some important things. And what are those important things? Have a look. If you guys are looking for the JEE 2022 crash course, well, let me tell you, on the actual Vedantu platform, right? Apart from all these YouTube sessions, on the actual Vedantu platform, the batch for the JEE 2022 crash course is going to get started, right? And you are just getting this, you're just getting enrolled into that batch by paying this much of amount, which is, there is some discount going on. Only in 9K you're getting enrolled into the batch which I'm talking about, which is there on the actual Vedantu platform, wherein we'll be training you personally in all the 3 subjects, physics, chemistry, as well as mathematics, till your JEE 2022. We'll be covering your whole syllabus in that batch, which is there in the actual Vedantu platform, right? Okay, we'll be covering the whole syllabus. We'll be giving you the study material, test series, everything will be provided to you. So basically, you are going to get trained by us personally on the actual Vedantu platform. But in order to be the part of that batch, you need to take this subscription, and there is some 50 to 60% off going on, correct? Right? So do take this subscription, which is just for 9K. Link is there in the description box of the video. Let me quickly show you how to get enrolled into the batch which I'm talking about right now. See, this is the video which you guys are currently watching, yeah? Just drag the video a little down. After dragging the video a little down, you need to click on this show more. After clicking on this show more, you'll be getting a lot of links over here, right? JEE 2022. For example, I'm clicking on this link, right? Okay, over here, wait, there is something wrong. Just a second. Just a second, I'll show it to you. Okay, this is the JEE crash course, right? This is the JEE crash course link, right? Which you are getting just beneath this video. JEE crash course, you need to click on this link. Well, after clicking on this link, you need to choose your plan, right? One is going to be light plan, which is for 9K. One is going to be the classic plan, which is again for 9K only, right? Basically, both these plans are same, right? And both these plans, right, it is just for 9K. Vedantu has kept absolutely just for 9K. Yeah? So do get enrolled in this batch by clicking on buy complete course. After clicking on buy complete course, put your number, and do not forget to use the coupon code. Let me show you the coupon code exactly. The coupon code is going to be your WBPRO, I guess, right? It is WBPRO, or on using this coupon code, you'll be getting some additional 10% off as well, right? Okay, so finally you'll be getting this course just for some 8 or 8,500 something. So do get enrolled. It's going to be highly beneficial for you, right? Okay, right, people? So do get enrolled in this. It's going to be highly beneficial. Okay, and in this batch which I'm talking about, we'll be covering your whole syllabus. Apart from that, test series, everything will be provided to you. At the same time, there will be the mock test, study material, everything provided to you in all the 3 subjects, that too, physics, chemistry, as well as mathematics, right? So do get enrolled as soon as possible. Now I'll meet you soon, tomorrow at the same time, right? Until then, you guys take care. Bye-bye. God bless you all and love you all. Take care, guys. Bye.